Okay, today we're going to be working with the discriminant and also finding the vertex of functions. So if we just want the x-coordinate of the vertex, there are several ways we could find the x-coordinate of the vertex. One is to complete the square, but another one is to use the formula. The x-coordinate of the vertex is -b over 2a. So this is the one we're going to use right now. So we plug in 6 for b and 1 for a. So we get x equals -6 over 2, which is -3. So the x-coordinate of the vertex is -3. So how would we find the y-coordinate of the vertex? If we need the y-coordinate of the vertex, then we take x equals -3 and plug it into our equation. Okay, pause the video and do the next one. To get the x-coordinate of the vertex, we use the formula x equals -b over 2a. So we plug in -2 for b and 1 for a, which gives us 2 divided by 2, which equals 1. So the x-coordinate of the vertex is 1, and if we needed the y-coordinate, we would plug that into our equation. Okay, try this one. Stop the video and find the x-coordinate of the vertex. To get the x-coordinate of the vertex, we use the formula x equals -b over 2a. So we plug in b equals 12 and a equals 2, and we get -12 over 4 equals -3. The x-coordinate of the vertex is -3. Stop the video and do the next one. To get the x-coordinate of the vertex, we use the formula x equals -b over 2a. So we plug in b is 18 and a is 3, and we get -18 over 6, which is -3 again, Now we need to figure out which one of these equations could possibly be the equation for the graph that we see up here. Now, we know that this graph has x-intercepts, +1 and +6. So if we use the x-intercept formula, we get x minus 1 and x minus 6. So there's our formula right there. Now look at these possibilities and figure out which one of these could possibly be the equation that is graphed on top. So we know in this graph the x-intercepts are -1 and -3. Therefore, the equation using the x-intercept form is x plus 1 and x plus 3. Now we're going to sketch the graph. Step 1, find the x-coordinates of the vertex. Equals -b over 2a, which gives us -12 over 4, which gives us -3. In this case, we're going to need the y-coordinate as well. So we're going to take -3 and plug it in for x. So we take x and we substitute x equals -3. So we know the vertex is at -3, -15. Now we want the x-intercepts. To get the x-intercepts, we set y equal to 0 and we solve for x. Since this cannot be factored, we use the quadratic formula. So now we plug in b is 12, a is 2, and c is 3. Now we simplify. Since we're trying to make a graph, we're actually going to get a decimal, and we're not going to simplify the square root. And -5.7. So I have x-intercepts, -0.6 and -5.7, and a vertex at -3, -15. So there's a quick sketch. The discriminant is that part of the quadratic formula underneath the square root. So if the discriminant, which is the part under the square root, is a positive number, you're going to get 2 distinct real solutions. If the discriminant equals 0, the whole square root is going to disappear and you're only going to get 1 real solution. If the discriminant is less than 0, if it's a negative number, then you're going to have a negative inside the square root, which is going to give you imaginary numbers or 2 non-real complex solution. Find the discriminant of the quadratic equation and give the number and type of solutions of the equation. So here's your equation. So in this case, a equals 1, b equals -8, c equals 17. The discriminant is this part of the quadratic equation right there under the square root. b squared minus 4ac. So for x squared minus 8x plus 17, the discriminant is 64 minus 68, which is negative 4, which gives us 2 imaginary roots, or 2 imaginary answers. For b, we have b squared minus 4ac, which is 64 minus 64, which is 0, which gives us 1 real solution. In our third example, we have 64 minus 60, which gives us 4. So we have 2 real solutions. In fact, this is a perfect square, so there are going to be 2 real solutions that are both integers.